Okay, now we are good to go. Mycotoxins, one of the important questions. There are in many forms, and but basically are just toxic, chemical compounds that are synthesized by fungi and mainly molds, and some of them are in grain, and it could be in the corn silage or in hay, and we had to be aware of that, and one of the perhaps important question that we get is why mold produce these toxins, and this is something that is still in debate, or something is unknown, and some of them produce it because that is what they do, and that's how they survive. But the production of toxins, right, seems to be a defense mechanism, when the environment changes, right? And some of these fungus, right, they produce a lot of these chemical compounds. Some are beneficial for us, and perhaps for cattle, and but a number of them are has a toxic effect for cattle, whether that is beef, dairy cattle, or small ruminants. Right? They are, when you look at the literature about mycotoxin, they are distributed, worldwide. It doesn't matter whether this is in the northern hemisphere, the southern hemisphere, east, west, central, right? There are about 400 or more mycotoxin that has been identified. They are persistent and stable, right? And they are present in many feed. Right, and I highlighted because most of us work with forages and grain, and we've been doing this for many years, right? And as the industry, particularly the cattle industry, and it's evolving and recycle some of these byproducts from the industry, right? I highlighted in red because we've been testing more, and we find quite a bit of mycotoxin, including this byproduct that they come as a recycle from the food, industry into the cattle production systems, right? So they do affect, and like I mentioned before, they do have some positive, some of them positive effects, some other negative effect in both people and animals, and definitely that cost an economic loss, right? When you look at, what are the most common molds and mycotoxin in dairy cattle, there are several molds, and perhaps one of the biggest group, right, is the Fusarium group, right, and they are able to produce a number of mycotoxin, and we measure a number of them, right, and fumonisin, the T2 toxin, this is the bimotoxin or DON, right, and nivalenol, right, and then there is when I did my PhD, I worked quite a bit on this, especially the ergodicaloid, and I work quite a bit on bull fertility, on the male fertility, right? Today we will talk about the female, especially in dairy cattle, but there is a same effect for the female, right? This is of concern, especially for those that are working on the semen company, right? On how we are feeding these male, and because they do have a direct effect, at fertility in bulls, right? And then we have the aspergillus, right? And they produce the aflatoxin and the ochratoxin, right? This is just a macro view. There are many more, right? But this is just a division on how each one of these mycotoxins are coming from, and some of these molds can produce more than one, right? So what are the factors associated with it? What trigger this production of mycotoxin, right? Most of the mycotoxin, I think it comes to the conclusion and that it's produced in the field, right? And some of the stress factor. I just highlighted things that last year, especially 2022, was a rough year, and in many sense here in the US, but also in South America. And so we have limited water, right? And stress plant, and a significant increase of insects, right, in cornfields, right? So most of the mycotoxin, we are now feeding most of that corn silage cows, so we had to, address some of these issues. They're produced in the field, and then the stressors are the ones that, trigger some of these. But also molds can produce some of these mycotoxin, during storage, right? So there is a number of things like temperature, humidity, the substrate for them to grow, right? pH and oxygen, this is important, especially when working on the pre-harvest and when we are chopping corn, right, to lower the pH quick, right? That really, stabilize the, the silo and remove the oxygen, and that really, really helps, with some of these production of mycotoxins, especially during storage. Crop rotation, right? And within crop rotation, specific hybrids that are perhaps more resistant, right? When we select this hybrid for corn silage, right? And some management practice, I'll chat a little bit about this and how we do things that I have a positive effect, especially to minimize mycotoxin and the stressors that I mentioned there, limit water availability, the drought, plant damage, insect, all these are, major factors that will cause some of these, molds to produce mycotoxin, right? So where and who produces the main molds and mycotoxin, right? The color of the mold, when looking at the color, that really is helpful, that helps you. But it's not a specific, right, to identify the mycotoxin, because of what I mentioned before. They can produce, several of these mycotoxin, right? But in general, as a summary, right, in the field, usually you get alkaloid, the trichothecins, right, fumonosins, zearalenone, right? And during storage, aflatoxin and ochratoxin, those are the major ones. And you can see here the color, some of these fungus, changes, some of them are red in color, right? And changes, and sometimes you see that in the field, right? When it comes to the analysis, I took this study, right, what they were looking at mycotoxin in corn silages, right, and TMR, and it's frequent to find mycotoxin, right? So these are, the top graph, it shows this, the prevalence of positive sample, meaning that it could be a positive sample, that doesn't mean that it's high, right? And you have, for three major group of mycotoxin, here are on the bottom of the graph are the major group. The TMR prevalence is on the top graph, and the corn silage, specific for the main forage, right, is on the bottom, of the graph, right? You see the prevalence for each one of them, and here you see, the sample size, how many samples they test, right? And here are the mean, and this is in ppb, part per billion, right? So this is the mean for those samples, right, from 884 part per billions, right? These are for each one of the three major mycotoxins you can see there. So it is common that we find these mycotoxin in the field. The most important from the cow, right? It is important, especially for those working in nutrition, to know which one of the ingredients are the one or the major contributors to the TMR. From the cow point of view, the most important is at the cow level is the TMR, what the cow is eating, and if there is any dilution effect or not, right? So there is a year effect. Some years get really high, some years get really low. So it really depends on some of the factors that I mentioned before. Right. Another question that is important is, could TMR be contaminated with several mycotoxins at the same time? And the short answer is yes, right? 57 to 87% of this, of this analysis come with 2 or more mycotoxins, right? So I'm doing an experiment now on transition cows, right? And because we see a lot of variation in gestation length and a lot of variation in colostrum volume, right? On top of what we already know about the health event and the somatic cell count and some of the metabolic challenge for cows. And what I see is that we get 5, it's very common to see when we see these herd that they struggle with some of these, to see an average of 5 mycotoxins, 5 major mycotoxins, in their TMR, right? So here is data from another large study here in North America. And so 39% of the mycotoxin were these 2, DON and zearalenone, 49% for this combination, DON and fumonisin, right? And 37% for these 2 mycotoxins. So what is the bottom message is that very likely cows are dealing with 2, 3, 4, or 5 mycotoxins or more, right? And these are the ones that we already know and the ones that we measure. but it could be a number of other. I'm going to make a few comments that I suspect there are a number of other things that we don't even know that exist, right? We don't measure because we just don't have the assay to test those, right? So these are data from the, North America, right? But this is just to get an idea about the prevalence, right? The prevalence of these positive mycotoxin, right, in North America. DON or mycotoxin, this is the most common that you see, in general, most of these mycotoxin. It's followed by fumonisin, zearalenone, and a number of the other ones, right? So, but these really changes depending on how what are the ingredients on a year-to-year basis, and what are the ingredients, right? I know that there is a number of variations, especially from North America versus South America, and versus what farmers are feeding in Europe, especially when it comes to these, by product. So the number of mycotoxin could change. But anyway, here is what we have. This is what basically sometimes we had to deal and address. And I have an example at the very end of my presentation. I'll go how to in a practical way, how to address some of these issues. What is the mechanism of action of the most common mycotoxin, right? Most of them, here is the number of, the most prevalent mycotoxins. That many of them share the same receptor, many of them share same pathway, right? But binding, it affects the DNA, right? And some of these mechanism of action, it inhibits protein synthesis, it inhibits, the metabolism of lipids, right? Stimulate, estrogens receptors. This is important, especially when feeding heifers, right? They could develop, the mammary gland because of a number of that could come from, these particular mycotoxin. Inhibit, again, protein synthesis and stimulate the adrenergic receptors, right? Like dopamine and serotonin. So these are just a number of things and how they work, at the cow level, right? So because a number of these pathway or processes are associated with inflammation, are associated with the physiological process in the animal, right? We know that most of these inflammatory processes, they also share common pathway, right? And one of the central organs is the liver, right? And it triggers these inflammatory processes. Mycotoxin is part of this inflammatory process. They are pro-inflammatory, right? And they trigger a cascade of events, on the cows, right? And we know that a number of them are immunomodulation, so meaning that they can, down-regulate the immune system, are pro-inflammatory, meaning that they could increase cortisol in cows, and also increase the cell oxidative stress, right? That is at the kidney level or the lung level, right? Something that I am doing lately is on gestation length. This is a very sensitive markers, and in many farms we monitor that, and I'll go through that one because some of these mycotoxin, especially in a long exposure, that could trigger increased cortisol, and that could trigger labor. And there is a practical way that you could see that in the farm, and then you put all the picture together, right? It may have a major impact on gestation length. And we know that if we change gestation length, especially the short gestations, right, that is where you see the most problem at the maternity, either with colostrum volume and with the stillbirth, and also early on in lactations, right, with all these metabolic problems in cows, right? So what are the threshold of mycotoxins in TMR, right? So most of these data come from guidelines from the European Union, right, the commissions and the FDAs that we have. And I think most of the data, especially the latest, publications on this topic, have shown that the threshold, perhaps to see the clinical signs in animal, are lower than what we see here, right? So, but anyway, I highlighted and read the one that is regulated for human intake. There is the aflatoxin, right? And So this is about 20 parts per billions, right? And milk, what is the limit? And then a number of the other mycotoxin, and it really depends because the ruminant has the advantage that it has the rumen, and the rumen has a little bit of the capacity to inactivate or at least degrade some of these mycotoxins, not all, right? But then I made a distinction whether they are young animal, they are like function like a monogastric, or they are just more developed, what they have developed the rumen, so they can tolerate a little bit more the mycotoxin. So when it comes to the mycotoxin, right, and most of these, what are the, the effect on cows? Usually you have the alkaloids, right, and that could be an issue on the cow. And then with most of mycotoxin, they have 4 different levels. It affects directly the rumen, right, and the rumen functions, right? Dry matter intake, it could affect that one, that trigger the inflammatory process and immunity, and it does have, affect milk and reproduction. And it affects both when it comes to reproduction. It affects the female and it affects the male, right, the bulls, right? So we will go through some of these, especially when feeding corn silage and feeding in transition cows, some of these wheat straw and prepartum cows, right? So here is the summary, if you want to look at, what are the main targets or the main organs that has been compromised with, some of these mycotoxins, right? So you have the 4 major tissues there, right? The mycotoxins and red, and what are the clinical signs? Some of them are, it could be subclinical, and some of them are, clinical, right? So the digestive system is important, and make a comment on this, especially for high producing cows. And there is something important, especially when we see this hemorrhagic bowel syndrome. So that could be an indication that you have major issues with mycotoxins in your TMR, especially when you see those cases, right? Reproduction is important also. And like I mentioned before, both male and female. And personally, I monitor quite a bit on this farm gestation length because it's a very sensitive marker. And we can do that almost, especially in any size, but in particular large farms, on a weekly basis. And you can see, right, changes right away. So you can do interventions before it became a big issue, right? And then the mammary gland, definitely, because some of these mycotoxin has a direct effect in the rumen, right? Especially in bacteria that are responsible for production of the, B vitamins. And one of these B vitamins are important for the keratin, production. And that is why somatic cell count, have a major spike when you're dealing with mycotoxin. And then there is others, associated with immunity, average daily gains, lameness, right, and changes in hair coat, right? So corn silage, right, and when we see the corn, we see the signs, visible moles, like you see here in the picture. These are usually, warning signs, at the farm, right? That means that there has been an increment. Remember that most of these fungus are, are coming from the field, right? When we chop some of these, we doing the corn chopping and the corn silage process, we bring some of these, fungi from the field to the pile, right, to the bunk, right? So when we have high concentration of these, depending on the year, you can have high concentration of these. That will trigger what we call the fermentation of, the plant protein. Bacteria, they can use the plant protein, but not a lot. But these fungi are, they help with this, fermentation process and make those, like split in a small part that the, later on some other bacteria could use it to grow. So what that triggered, right, is an favor that overgrowth of undesirable bacteria, right? Especially when you look at something like this, right? And that is what we see this, growth of Clostridium, especially Clostridium, right? Perfringens, right? But also Listeria, right? Listeria and E. coli. So those are the bacteria we do not want to deal in the corn silage. So, but depending on how is the contamination coming from the field, you might end up with this, and that will change absolutely the quality of your corn silage. What this poses, a high risk for this intestinal, right, hemorrhagic syndrome, right? And what do you see there is we see this spike, especially in high-producing cow, right? Because the dry matter intake, right, on a body weight basis, the dry matter intakes, they eat a lot more compared to either, early on in lactation or low cow, right? Or even, dry cows, right? So they're on a body weight basis, these cows are more affected by these mycotoxins. So when you see some of these clinical signs, you had to think and do the reverse process, right? And start looking and thinking about this, that it might end up coming from your, your corn silage, right? So mycotoxins, we also know that has a profound effect in ruminal protein synthesis, right? And the rumen in general, there is two major, point of contact for mycotoxin. One is the rumen, and the other one is the intestine, right? So the rumen is the first one, right? And the rumen can degrade some, but not all, right? It has a little bit of buffer compared to poultry and swine. Cows are a little bit more tolerant, to mycotoxin, right? But once the cow eat, I really like this study because they show what we see in the field, right? These are 3.1 ppv, part per billion of DON in TMR, and the total TMR that the animals were eating. And so that has a significant effect in the rumen, especially bacteria, because the metabolized protein drop at about 20%, right? That has a substantial change, right? Especially for those working in nutrition, right? On how, you have to think about how you're going to approach this and how you're going to compensate, right, some of these drop, because they have a profound nutritional effect at the rumen level, right? So this is more on swine, this study, but I really like it because it shows what we see also in cattle, that mycotoxin reduce about 30% of the growth, 30% growth, right? And of which of that, out of that 30%, 85% is due to feed efficiency. So it's a significant effect on feed efficiency and how much they can, transform from that feed into the muscle, right? So here is I really like this study because it shows this is the mean growth, right, response, right? And here are different things, right? This is digestive bacterial infection. This is poor housing, right? This is just LPS, like E. coli challenge, right? A lot of E. coli challenge. These are mycotoxins, what we're talking about now. This is why the 85% come from the fraction that is due to change in feed efficiency, right? Parasite infections is another example, right? And respiratory disease, right? Each one of them will have it, and they will have a drop in growth, average daily gain, right? But each one of them will do it in a different way, right? So in the case of mycotoxin, is 85% is because of a reduction in feed efficiency, right? Think about poor housing, because we are always dealing with performance in cows, right? And sometimes the first things that we have is it got to be mycotoxin, and that not always is the case, right? When you have also cows losing weight prior to calving, this is almost always bad for the cow, right? Regardless whether or not you have mycotoxin. So we had to make a distinction whether we are dealing with mycotoxin or we are dealing with cow comfort and some other problem, right? So I'm going to share a little bit before I go into the practical aspect, a few studies that, right, more of the latest studies. There are many, right? And when it comes to, testing some of these binder, right? In the US, we don't have a specific binder has been approved by binder of approved by the FDA, right? In Europe, it's a little bit different, and when it comes to some of these binders, especially in poultry and swine, so I'm talking about cattle now, right? So here is an experiment, and it has a little bit limited number of animals, but it shows it's a really nice data that shows how mycotoxin work. Right. So there were 3 diets, basically here in a 3x3 Latin square study. They used 12 cows. So they use a clearing process of 2 weeks and then an experiment, time of 21 days. So they do that 14 days, 21, 14 days, 21. right? And they test 3 different groups there. A control group, that these are the level of mycotoxin that were in the diet, right? The mycotoxin TMR, these are the contaminated diet, right? And then they add a diet with a binder and deactivator, right? And basically the properties of this binder, I just want to understand how the binder of what they were trying to do in this experiment, right? They have a combination of 3 major things, right? They had an inorganic to deal with aflatoxin, right? They have a bacteria, right? And deactivator to deal with some of the hard, more difficult toxins, right? And some specific enzymes there. And then it has an organic, component in their binder, right, to deal more with just, to help with this, to repair the tissue. It was a blend of, plant extract and algae. What this study, for those that want to read the study, they just, here is the study, but just the basic summary, the TMR with this binder were able to revert most. They didn't do 100%, but they were able to revert most of these negative effects, especially in digestibility of the fiber, right? The immune and metabolic, reactions on cows, and but they didn't have, fully recovered milk yield. So milk still was, was low. So another things that I really want to mention, because there is a number of other, when we see what is available as when it comes to these feed additive or binders that we use in or that are commercially available for cows. This is one, because there are some others that use these, bacteria, the Bacillus subtilis, and in vitro have shown that they have these, reduce the number of the fungi, right? It has a profound inhibitory effect. But also the most important is that reduce the production of these, mycotoxins. So a number of other binders are in a way similar to this. So it's a combination of inorganic, organic, and some of these, bacteria, right? And we've seen that in the field that has very, very good, response when it comes to, cattle performance. And I'm going to share 2 additional resources that I think are, at least it really helped me. One is about, when it comes to testing this binder, what are the methods, what are the data that we already got available when it comes to binder. So this paper provides really interesting information. It's a really nice summary. And then when it comes to this dealing with mycotoxin, right, the prevention or the management approach, it really provides an overview of different things that I'm going to cover in this webinar today. When we observe the clinical signs and the increased contamination in mycotoxins, what we can do, right? And so basically, you're going to have these, additives, right? And you're going to have the inorganic, organic, organoclades, right? Organic or activated charcoal. These were the earlier version, right? And then you have these deactivators that are either enzymes that are synthesized by the specific bacteria or a specific microorganism, right? And that produce some of these, bioactive component that neutralize some of the effect of the mycotoxin, right? In the US, there are no product approved, by FDA as binders, right? And something important when you're using a binder on the farm, that you have to be fully aware that they also bind, right, vitamins, right? And they do both the water soluble and the lipid soluble vitamin, right? And it could reduce about 20 to 34%, right? Depending on the vitamins, it can have a significant effect. So you're going to have an addition there, but also there is a side effect on this. There is also a binding effect for mineral, especially the most important for, especially in dairy cattle or for growth, that are, copper and selenium are associated, both are very important cofactor of many enzymes. And another things that I highlighted in yellow that is also bind to amino acid, right? It could drop about 45% of your amino acid in the diet, right? Especially lysine and methionine, right? We do need, those are absolutely important, especially for health and performance in cows. What is the absorption capacity of these binders. So absorption is the capacity of the binder, to be able to bind there and bind in a way that is, is strong and to remove that effect from when mixing in the TMR. So as you can see here is the list of binder, right? The bigger the font, the more binding capacity, absorption capacity, right? The more able to, so this is the regulated, this is regulated in our food system, right? And it's perhaps one of the easiest to control, right? In that way, because it has a high absorption capacity, right? For most of these binders. So inorganic binders will deal with this, without much of a problem. And then as you go down there, you have most of these ones, especially these are the group of mycotoxins, very difficult to bind, right? But either inorganic or organic, and then we'll have to use a different strategy to be able to control those. And something important with binder is that they work best with a low pH, right? There is a pH sensitive, in these binders. So the lower the pH, the more able, to work compared to when there is a high pH, like in the intestine, right? So we did a genomic project several years ago, and was part of a large group led by Dr. Pinedo. And so during, we had 2 years that we followed this farm. There was 12,000 cows that we genotyped, and across the US on 16 farms. And there was 2 full years. So I was working on 4 farms. And what I noticed, when we put together the data is, we have this analysis in mycotoxin in TMR, in particular in TMR, and in some of the ingredients like corn silage, right? Cows that were, those farms that gave emphasis in their selection index, right, to, health trait, they were important for them in their health trait, right? And without giving up milk and solid, of course. And they deal with mycotoxin in a different way. So, and this also opened for me, this is a more holistic approach. It appears that cows can tolerate more, right? If in our selection index, we do provide more emphasis on health, right? The cows are able to deal a little bit better with some of these pro-inflammatory chemicals, right? So I did mention to you early on that gestation length was a marker that I monitor. And here is the reason why I monitor. These are Holstein cows in the US or worldwide Holstein cows. They changes from breed to breed, and it also changed depending on how you are selecting. Some of the beef cattle, for example, has a little longer gestation length than dairy cows, right? So, but Holstein cows, these are, the mean plus minus 6 days, what the gestation length is based on current or the most current data, right? And then you have a distribution of gestation length, right? Here is the distribution, right? 255 to 69, these are what we call, right? The range of the gestation length is from 255 all the way up to 296, right? Or 97, right? That is the whole range in gestation length, right? Most of the cows, right? 82% or 83% are going to be on the average, but you have about 10% of the primipar cows, right? They had usually heifers has a little more shorter gestation than mature cows, right? So, and about 8 to 10% are going to be short gestation, right? But when you look at their performance, how these cows do on a real farm, you find that most of the problem, the health problem, these are the not all, but a big majority of these cows will have problem in the maternity, will have problem early on in transition cows, especially with uterine problems and morbidity, getting sick, including mastitis, right? That high risk for choline because of some of these problems, and it does have an effect on milk yield, right? We know that. We know. So what we have done on the farm is I keep as a goal less than 12% in gestation. And I'm using gestation length as a biological marker on farm to assess inflammation, because I know when we trigger inflammation, that also increases cortisol in blood. And cortisol is the driver to trigger labor. So the cow go in labor because of this chronic exposure to some of these stressors, right? So, and how high it could go? The highest that I've seen it is 30%. So even in Holstein farm, 30% of your gestation, this is a real issue for the cow, right? So when we trigger this, and then when we look at some of these mycotoxins, these are the things that we are seeing, right? Not all are due to mycotoxin. For example, there are other issues associated. So, but this is something that helps you to pinpoint some of these problems, especially when you are reading and getting back the result from the lab, right? Your gestations are associated with sire. The sire is the most weight on gestation length, right? So the sire could have short or long gestation length, right? Depending. The gestation length, the sire has a significant component. Summer effect, usually short gestations, right? Twin pregnancies, almost always you're going to have short gestations, right? Cows losing body weight prior to calving, that trigger also all the process inflammation, and this will have, you know, an issue with gestation length. Poor cow comfort, right? The cow comfort will have an issue because it's associated with dry matter intake. It's associated, especially prepartum in cows. You know, in the close-up, you know, the last 60 days in gestation, they will have an effect, right? And think about cow comfort as the 5 freedom of animal welfare: access to feed, access to water, thermoneutral, right? Be able to express natural behavior, laying down, eat, walk, right? Not afraid of people, right? And free of pain, right? And feeding Dika diet more than 40 days, and some other plant toxin. And some of these also ingredients that we feed. There are some ingredient, especially protein, right, that it could trigger, you know, plant that we use for, you know, high in protein, that they could trigger also, you know, short gestation depending on the inclusion rate on some of these diet. Poor health performance are not always associated with mycotoxin. This is a problem because that creates a little bit of frustration. Sometimes we use the binder, but we don't see much difference, you know, in cow performance. We still see some of the problem, right? A broad spectrum, you know, binder will not solve, you know, or not likely solve, you know, the poor cow comfort or inconsistent management. I think that is an important message that I really want to leave here clear. So I'm going to share how is the selection process of the binder, and what is the science behind this binder. I really, really like, I think the poultry and the swine industry have done a, you know, tremendous effort in understanding some of these science. Some of them come from even earlier than the 80s and the 90s. So very interesting information. You know, here is an example. This is aflatoxin, right? The one that is regulated in most of the, you know, worldwide, right, because of the impact in humans, right? This is, you know, high absorption capacity. So what that means, so they were testing 3 different binders. They were testing the organic binder, regardless of the name. If you know, you can read the paper and read the specific things that they were using, right? And they were using also 2 different pH, you know, low pH or high pH, right? And so they were using organic binder, the red one, and these are, you know, the yeast, the bacteria, right, or deactivated. When you look to the aflatoxin, when it comes to the aflatoxin, you use inorganic or an organic binder, and you have really high absorption capacity. So that is the main message. So aflatoxin is fairly simple, right, to absorb, right, and using inorganic or organic binder. Now, when we come to, you know, DON, or this is the mycotoxin binder, now this one has a really low absorption capacity. You know, it's about 10 to 20%, regardless of which one, you know, this is either inorganic, organic, or yeast, right? This is why, you know, when we look at in some of these, you know, selection process for the binder, you know, it is important that you have a combination in the binder that is combining some of these technology, right? The inorganic, like, and I share with you what are the inorganic or organic organoclade, right? Or organics, and some of these deactivator, right? The activator could be the enzyme, it could be the bacteria, right? The ill-formed bacteria that probably, generate some of these compounds that inactivate, right, the enzyme. So this is basically one of the reasons, how the selection process is broad spectrum, because we are dealing with more than one mycotoxin. You are not just dealing with only one. Right. When we did some of these transition cow, I found an average of 5 mycotoxins that were medium to high level, right? Especially when dealing with some of these problems, right? How to determine if there is a presence of mycotoxin affecting her, right? So basically, there are 3 things that I do. I observe and assess. One is at the ingredient level, and another one is at the cow level, and another one is at the facility, especially the feed bank and the TMR, right? So those are the 3 levels. And I go through these questions, right? And I see some of these ingredients, such as, visual observation, right? Animal feedback. When I see that they are struggling with some of these questions, they all come yes, and they see some of these. If the answer is yes, it's not like you are gonna trigger and start using the binder, but that really, trigger the next step, that is to the testing, right? This is when test TMR. The first one is we start with the TMR, and then we might go to the specific ingredient, right? If the farm has the ability to change some of the inclusion rate in some of these specific ingredients. And we look for potential mycotoxin contamination, right? Regardless of the level, we are looking, here is the contamination level. And basically what, and a visual thing says, when I walk through the farm, this is what I see, the corn silage, look at the maternity, especially when they have low colostrum volume, right? This is something that I really pay attention, and short gestation length, and they have a little bit of diarrhea, inconsistent intake. Some cows develop cyst. We check the cows and we see a bunch of cows more than normal, develop early on in lactation in the fresh pen before 30 days in milk already with cyst, right? On a lot of cows, with metabolic problem or increase in somatic cell count, right? When we do that, then that is what triggers the sampling. Getting the sample perhaps is the most important. I'm going to make a comment here that safety comes first, right? You're dealing with mycotoxins, and I think those individuals who are collecting the mycotoxin need to be fully aware and use protective, specific equipment, the mask and the gloves, right? Be aware of variation, right? If sampling the TMR right after you unload the mixer, that is the best, most representative what the cows are eating. The cow at the end of the day are eating something different in the diet because of their selection process, right? And so the TMR right there, an ingredient, especially forage unconcentrated. Most of the variation when it comes to errors, it comes through this sampling process. What is the protocol for sampling? Many of the labs, and I have some resources, they already provide, explanation on how you collect, and many farms that I work, they already have the protocol on how to collect this, sample, right? So you collect the sample. Once you collect, you pull the sample, right? And here is a little bit of variation also, 8–10% of the error in that pool sample. And then from that pool sample, you make one sample that you send to the lab, right? This is the sample that I send it to the lab. There is a lot less variation because they have a standardized protocol and standardized quality controls, at the lab, right? I just want, highlight how important is the sample collection, because that is what the information you are going to get, to make a decision at the farm, right? So once it comes to submitting the sample, right, about 2 pounds, you can use a vacuum seal or a Ziploc, a regular Ziploc, remove the air from those. Most samples, you got to be refrigerated or freeze. You could freeze them until you do the analysis, right? Concentrate or high samples do not require refrigeration or freezing. Do not freeze samples that are going to be for mole or yeast counts, right? Many people use this one, the yeast count, and a number of farms that we go, they do also this one. And And I think it is important, you know, the number give you the context, right? It is important to see a specific ingredient might be more contaminated than other, but a low number does not mean that you don't have a problem, because some of the mycotoxins, especially for forage, they might come from the field. They already released the mycotoxin. So a low count is not necessary that you don't have the problem. Right. So, and just want to make a point on this one. And then it comes the laboratory analysis, right? The mycotoxin. There are different panels, 4, 7, 14, you know, mycotoxins, right? Panel. And there are different techniques. You know, I highlight in red what for me is the gold standard, right? I highlight in red. This is for me the most important, right? You can use lateral flow ELISA. These are rapid but have limited information, and HPLC also is quantify one toxin of known concentration, but this one, the mass spectrophotometry, this is the detection of multiple mycotoxins. This is perhaps the most important testing, and I'll share. There are several labs, you know, here in the US and Europe. And some of the countries in South America also, you know, have this technology capacity to measure mycotoxin, right? So how do I interpret the information? So I send the sample, I made an effort to get the representative sample, I send it, and it comes back. So now I had to do some, you know, interpretation of the data when it comes to managing this contamination, you know, risk. And I really like it if you go to these are resources, you know, that are available on the website. I place kind of the link there, and you can find this information online. And here is, you know, these are approximate ranges, and we know that some of these negative effects are much lower than the threshold that I initially mentioned to you, right? But anyway, we start looking at kind of the low, medium, or high, right? The problem with some of these building some of this information is that we don't know how much the interaction between the mycotoxin. We don't know if this is an additive effect, it's a multiplier effect, right? But that gives you an idea on how you manage. Every time that you are more, you know, in the medium or high risk, then you had to do something with the cow, right? You had to do something with the, you know, with the feed ingredient that is affected, right? So here is the Dayland laboratory also provides similar information, or the Rock River, and there are some others, you know, labs that provide these, you know, essays and panels for mycotoxins and they list on their website the price, right? And they provide the information also on how to interpret the information, right? So now comes to the prevention of these mycotoxins require, you know, an integral strategy, right? So the most important of these, especially, you know, forage quality, there are 3 things that makes a good farm, right? 3 areas that really, you know, set aside the best farm. They have good forage quality. They made a significant effort on that. They have a simple but very effective transition cows, right? And they have a very simple but effective replacement program, right? Those farms that I see consistently, they really do this. And what they do, and I highlight this paper because I really like it, they do mention a number of these things that we see in the field, right? Management prior to harvest, right? You know, it's an open sky business. So we do not have much control of this. Unless that you have irrigation, you don't have much control on water, right? But control of the insect and fungicide, you know, that is also another option. There is a number of farms that are trying to get away from the use of chemical, right? So they are trying to come up with some other, you know, alternative. But anyway, water, you know, and the water drought, specific variation, that will, you know, cause an issue. And they are making emphasis on selecting a specific, you know, hybrid that are more tolerant to these mycotoxins, right? Then it comes the harvesting, right? The corn harvesting, right? The chopping, especially the dry matter, right? That the chopping is perhaps the single most important when you initiate that chopping and the logistic that goes around, especially for big farms, and the particle size, right? Those are important because these are going to be directly associated with fermentation, right? And the silo. We would really need to lower the pH, you know, quick on this pipe, right? Quick fill and compaction, chopping height relative to the ground. The lower you go, the more mycotoxin you're going to collect, right? And sometimes this is a compromise because you run out of forage and then you had to get the most. But you know, when you go lower, you bring a lot of more mycotoxin. Mycotoxin, especially molds, are part of the soil. So they are there. The closer you get to the soil, the more likely you get mycotoxin, right? Inoculants, I always get this question. Inoculants and plastic film, they are absolutely effective. I think there is a lot of research that shows they are effective, especially to reduce oxygen in the bile, but has no effect on existing mycotoxin in plants. So if you already got mycotoxin in the field, so some of these, and that is important also to set the expectation right? Okay, we're going to use this one, but this one may not have any effect on mycotoxin that are already in the plant, right? But it will do help future growth, especially with molds, right? Storage, maintain, especially keeping that, smooth face of corn silage, hay, straw on the roof, and grain, especially less than or 13% humidity. And then it comes the mitigation. Now you have all these pre-harvest and harvest, and now there is another option also for mitigation using the binder, and you might need to adjust a little bit the ration. Okay, here is an example. I brought an example of one of the farms that we had to work with, and it has a lot of issues on transition, a lot of problems with colostrum, maternity, short gestation, a number of things. And so this is, some of the farms that they don't necessarily can change. They don't have any other corn silage, right? That is what we have to feed the cows, right? And there might be an option to increase the inclusion, to manage a little bit inclusion. If the inclusion could be managed, you could do a lot without spending, spending money in some of these binders. But not always that is an option, right? So here it was 4 combination of mycotoxin. All these mycotoxin were, remember the yellow, the orange, and the red, graph, they were all medium or high, right? And the risk of, part per billion, right? So what is the management strategy for it? The first one, that sometimes we do this conversation and discussion, and so what was it? These are the facts. No matter what, this is what the mycotoxin will do to some of these cows. We don't know whether or not they are, antagonic or additive or multiply, but we know individual, this is what they do. Right. So step 1, unless that they cannot change the inclusion rate, just to have a dilution effect, for something that is more clean, right? So the step 1 is the broad spectrum binder, right? It's a combination of both inorganic, organic, and deactivator, right? And there is a number, I think effective in available in the market, right? The step 2, the binder is not the only step. Right? I know I'm using a binder. I had to adjust the ration because it will have a binding effect not only in mycotoxin but also in vitamins and minerals, right? And some of these mycotoxin has a direct negative effect in the rumen and those B vitamin, the B vitamins that are responsible. One of them, biotin, are responsible to produce, the keratin plant, and this is why cows struggle to seal the teat canal, and they develop, increase the somatic cell count, right? So I know, especially in high-producing farm, I had to adjust my vitamins, right, and antioxidants, especially vitamin E and selenium, right? Depending on the inflammation, in this particular case, we did have, up and down, the fat. It was a depression in fat, so milk fat went down, right, same as milk is. So you had to use some of the buffer, right, just to address a little bit some of these stability in the rumen, right? And then we use the number 1, the rumen protected B vitamins and amino acids. A little bit, 15, depending on each farm and depending on the expenses that they cost. So every year is different, the strategy, because it really depends, the feed cost, the milk prices, all these are factored in some of these decisions, but especially because we need to address some of the health events, choline and methionine that are important, right? All these require, there is a direct cost, right? There is a direct cost for the ration adjustment, right? And you have to balance and take into consideration the cost and the benefit for the cows, right? So what are the management priority at the farm, right? The most important one, the diet is done, cow comfort is the top priority because that determines, dry matter intake. Without that, it has to be that important. You won't be able to fix much, when it comes to the binder if you don't fix the red one, right? The inclusion of the broad spectrum binder is important in your discussion, especially when you work with your client, at least in some of these points, the absorption capacity, what are you dealing with? Some of them, for example, Dawn has very low absorption capacity. So you might be forced to use some of the deactivators. Right? It has to be reversible, so it has to be binding, a strong, binding, specific, safe, right? For cow, has to have research and data, right? That is the most important. Priority for group, definitely transition cows are very sensitive, high producing cows and replacement heifers, right? And then rumen protected B vitamins, choline, antioxidant, and buffer, because they are absolutely involved in the production, health, welfare, and all these components associated, with performance on a farm. And the mycotoxin some of them has a direct effect, right? The cow can produce much of these B vitamins in the rumen, right? And but with mycotoxin will have a significant reduction, more than what the cow can tolerate, and then they will go through suffer all these metabolic pathways on the cows. So once that we could remove, lower the inclusion of contaminated ingredient, this is the best, holistic approach, but not always that is the case, right? Ideally, I would like to see, hay, especially if those farms are feeding wheat straw, right? And to cows, these are particular farms, they feed about 30%, right? Or the wheat straw and the prepartum diet. So, and avoid something like that, right? Sometimes, you store outside during the winter, some of the fungus, they grow in winter, right? And they release a lot of these mycotoxin, specific, temperature dependent. And then they seem to like the winter. And they contaminate, so that give you some flare up when you are feeding some of these ingredients, right? So with that,